In this next project, we're going to be talking about tangents. You may recognize the word tangent from some of the CAD work you've already done, but let's really get in depth and talk about exactly what is a tangent. A tangent is a line or an arc that touches another arc at one point and only one point. As you can see here, this line is sort of having a glancing blow, if you want to call it, just barely touching this circle and barely touching this circle. Those are the tangent points. So this line is touching this circle at that one point and only that one point. Doesn't touch the circle again. Down here, it touches a different circle at this one point and only that one point. Now you can also have circles or arcs that are tangent to other circles or arcs. So here you have this circle on the inside is touching this bigger circle on the outside at this one point and only one point. Over here you have this smaller arc being tangent to these two circles at this point. At this point, that little arc only touches those two circles at those two individual points. Likewise, this larger arc, where you can see the tangent points are on the inside of this arc, so they're internal tangents. Now, what exactly is not a tangent? Well, here you have a line, or technically a segment, that actually stops and terminates on the edge of an arc or a circle. So it would seem like that is touching at one point and only one point. However, this is technically not a tangent. If this segment were to continue as a line, it would end up touching the circle again, as you see in this picture right here. You can see that if we were to extend this, it would touch the circle at a second point, in which case it is not a tangent. Now, I have to say, tangents are so hugely important, and you probably have recognized them in the CAD exercises of like the spinner or the connecting rod, where you can actually see that there are tangents in the fillets and the rounds that you use in CAD. But tangents are used in all kinds of products everywhere. It is so important to product design. If you are interested in becoming an industrial designer or a product designer or a design engineer, you better learn how to love tangents. They are in everything that you might touch on a daily basis with your hands, a mouse, and yes, that Xbox remote, and things that you actually touch with your backsides. Yeah, that chair, and well, that too. So let's get on and talk about how we might draw and sketch using tangents. So the next project involves you designing a wooden toy that's going to include tangents. Here's an example of a simple sort of wooden toy helicopter that incorporates that idea of geometric tangents. So simple circles and arcs and lines that are tangent to each other. So let's explore this helicopter a little bit more deeply. Okay, so here's a close-up of our helicopter, and let's pick out where the tangents are. So again, there is a curve that's curving, and then that stops being a curve and starts becoming a line. So there is a tangent point right here. So if I were to mark, there's a tangent point right there. And then there's a line that stops being a line, and it touches this arc at one point and only one point. So there's a tangent point right there. Again, this arc comes around and then becomes a line. This line touches that arc at one point and only one point. The line turns into an arc here. This arc turns into an arc here. This arc turns into a small arc here. This small arc blends into this arc down here. This arc blends into a line. This line blends into an arc. This arc blends into this smaller arc. This smaller arc blends into a bigger arc. And there are our tangent points. So if we were to count them, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 tangents. But now the question is, how many of those are arc to line or line to arc tangents, and how many are arc to arc tangents? So let's go ahead and count those. So we have arc to line to arc to line, so that's 3. line to arc, 4, arc to line here, arc to line there. So that was 6. So there are 6 line to arc or arc to line. So arc to line. And if we look at the arc to arc, we have this small arc laying that big arc, so that's 1, big arc to small arc 2, small arc to small arc 3, small arc to small arc 4, and small arc to big arc 5. So there are 5 arc to arcs tangents. And 6 plus 5 is 11, so check. There you go. There's an example of where arcs are in a design here that I've given you. And you should hopefully notice that these will show up in Onshape or any CAD software where you can create these constraints where lines or arcs need to be tangent to other arcs. So let's explore what this looks like as I sketch it out on paper and what this might look like if I were to create this in CAD. Okay, so I want to discuss and show how this helicopter design is going to be sort of how is this brainstormed? What does this look like as a sketch? And you'll notice on the sketch paper, I'm going to start with sort of the major geometry of this. So when I look at this design, the major geometry is this large circle. And I might actually place that large circle at the origin, maybe if I were to create this in CAD. But so on paper, what this looks like, and again, you may notice that I'm going to start with light construction lines, and I'm going to sketch something that roughly looks like a large circle. The top edge is just simply a line that is tangent at this one point. I may draw the thickness of the helicopter tail and draw that right here. Notice there's nothing tangent here. But over here at the end of this helicopter, there is going to be an arc that's tangent to the line at these two places. Right, so this line is touching this arc at this one point and only one point. Likewise, this line is touching this arc at one point, only one point. There is a blend here, and I'm going to sketch that as an arc that looks something like this. This arc, so this line is tangent to this arc here, and this arc is tangent to this arc roughly around here. Down at the bottom, I may have draw, right, so this is sort of the skegs, the little skids down at the bottom of the helicopter, and there's a line that is going to be just a horizontal line. It's going to be tangent to both of those arcs. So again, there's a tangent point here and a tangent point here. There is a blending between this large arc and these two smaller ones. So again, I'll draw that as two lightly sketched circles in such a way that it shows that it is touching those arcs at one point, only one point, so it has those tangents. So if we recall, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 tangents. 6 of which are line to arc or arc to line. So here's arc to line 1, line to arc 2, arc to line 3, line to arc 4, this arc to this line 5, and this line to this arc 6. And the other ones are arc to arcs. So I have an arc here, 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 and here. So that's 5. So that gives you a total of 11 tangent points. Now, this may look a little bit messy, but I can always go back in and I can kind of darken in the parts of this design that I would like to keep. Right, so all the other lines were drawn with light construction lines. Now I can begin to sort of thicken and darken the parts of this geometry that I'd like to keep. And it begins to reveal itself a little bit better. And there we have this rough idea of a helicopter. And yes, I can put in a window here. And again, circles make great windows. It may not look necessarily like the most realistic window, But for a wooden toy, it is super easy to draw in CAD and super easy to actually cut in wood. All I actually have to do is get a large drill bit and drill that hole out. I don't have to do anything fancy. There will be a hole over here, and that hole is going to be at the same center as this arc. There will be a little hole here for the little rotor on the tail. And likewise, if I were to take a look at the centers of these arcs down here, I would put little axle holes for the axles to go through, and then I can put the wheels on. But there's the basic idea for brainstorming of this helicopter design, and you can see the full circles that I've drawn. This method that you use for brainstorming happens to be the exact same method you'll be using to create your toy designs in CAD. So let's watch the next video and see how we'll do that in CAD.